In the previous couple propositions, we made inferences from the equality of, say, alternate angles, or two angles being together two right angles, to the fact that two lines are parallel. And in proposition 29, we're going to start from the fact that two lines are parallel and make inferences about angles. So let's check out the text. A straight line falling on parallel straight lines makes the alternate angles equal to one another, the exterior angle equal to the interior and opposite angle, and the interior angles on the same side equal to two right angles. So we're going to break this apart and see what he's talking about. So what we have is, we've got the straight line EF, that's going to be the line EF. That's going to fall on two parallel straight lines, AB and CD. So note that in this proposition, it's given that AB and CD are parallel. So that's why I say we're starting from that instead of concluding to that. And we've got it, those two being cut by EF. And similar to the previous diagram, this is going to be G, that point right there, and this one's going to be H. And this proposition has three parts. The first part is, if AB and CD are parallel, I say that it makes the alternate angles AGH, that's over here, AGH, and GHD equal. That's the first part. So if the two lines are parallel, then the alternate angles are going to be equal. The second part, the exterior angle, EGB, is going to be equal to the interior and opposite angle, GHD. That's the second part. And the third part, the interior angles on the same side, namely BGH and GHD, equal to two right angles. So let's tackle the first part. The first claim is that the angle AGH is going to be equal to the angle GHD, that we have the equality of these alternate angles. And how is he going to go about proving this? He's going to assume the negation, or if the angle AGH is unequal to the angle GHD, if those two are unequal, then one of them is greater. And he says, let the angle AGH be the greater one. So we have this one over here. So I'll mark the greater one by the double arc, like so. Now what we're going to do is we're going to let the angle BGH right here be added to each. So we've got the angle AGH, and to that we're going to add BGH, and we've also got the angle GHD, and again add the angle BGH. So let's record what's going on here. So remember, we're supposing that AGH is greater with respect to GHD. But then, if you take AGH and add to it BGH, then those two are together two right angles. As he says, but the angles AGH and BGH are equal to two right angles by proposition number 13. Notice we have the straight line coming across here, EF, and these two are adjacent angles, and together they must be two right angles. And it follows from this that these two angles, here and here, since AGH and BGH are together two right angles, recall that GHD was lesser than AGH, it follows that BGH, this angle here, and GHD are together less than two right angles. But if those two angles are less than two right angles, then we have these two angles on some one side of the line cutting across two other lines being less than two right angles. And the fifth postulate, also called the parallel postulate, says if that happens, then these lines, A, B, and CD, will have a meet. They will intersect somewhere over here. That follows from postulate number 5. As he says, but straight lines produced indefinitely from angles less than two right angles meet. Therefore, AB and CD, if produced indefinitely, that is to say, if they're extended over to the right, they will meet. But they do not meet because they are, by hypothesis, parallel. Notice that the fact that these two meet, it contradicts the given, which is that A, B, and CD are parallel. So we have the absurd situation in which we have two lines being parallel and not parallel. Hence, the supposition that generated this absurdity, namely the inequality of these two angles, must be false. And therefore, we conclude that the angle AGH is not unequal to the angle GHD, and is therefore equal to it. So now we have the equality between these two alternate angles, given that AB and CD are parallel. So that takes care of the first part of this proposition. We have that AGH is equal to the angle GHD if AB is parallel to CD. And now we move on to the second part, which is to show that EGB is equal to GHD, that this exterior angle is equal to the interior and opposite angle on the same side. And how do we prove this? Again, the angle AGH is equal to the angle EGB. So you're saying that AGH is equal to EGB. And why is that true? Well, these two are vertical angles, and we simply use proposition 15, which says that vertical angles are equal. Therefore, the angle EGB is also equal to the angle GHD. So you're saying that these two are equal, but AGH, remember, that's in turn equal to GHD. Hence, we have the equality of the angles EGB and GHD. So at this point, we have the equality of EGB and GHD. And now what we're going to do is prove that BGH, and GHD taken together are two right angles. And how do we show that? Well, we start from this fact that we just proved, and he says, let the angle BGH be added to each. So to EGB, we're going to add in BGH, and same thing for GHD. Now notice that EGB and BGH are together two right angles. Therefore, the angles BGH and GHD are also equal to two right angles. Recall the reason EGB and BGH are together two right angles is because we have a straight line, and those two are adjacent angles, so they must be together two right angles by proposition number 13. And it follows immediately that BGH and GHD are equal to two right angles, because we added the same to things which are equal. So just to recap everything that we've demonstrated in this proposition, given that AB and CD are parallel, EF cuts them both, we have the equality of these two alternate angles. We also have the equality of this exterior angle and this interior angle on the same side, interior and opposite angle on the same side. And lastly, we have the fact that this angle and this angle are together two right angles. And we should carefully note that this argument did use the parallel postulate. Right here, postulate number 5. Remember, we used that when we said that if this angle and this angle were together less than two right angles, then the lines AB and CD, if produced indefinitely, would meet somewhere over here on this right-hand side. So here's the parallel postulate right there explicitly, and the inference made using the parallel postulate as one of the premises of the argument.